Okay, so you will do two things in 60. One is multiply, one is divide. Today it's just what?
Multiply.
Okay, so this is divisions tomorrow, multiply today. All right. So here they talk about how to multiply radicals, but let's you and I discover it. Do this for me right now. Just get me the answer to this. Don't say it, just do it. And I'll call on somebody. Final answer, John.
Would be 6.
Well, how'd you get 6?
Well, I reduced it. The square root of 9 is 3, and the square root of 4 is 2.
Okay, so you did this, and this, and you're saying the answer is 6, correct?
Yes.
Okay, he's right. Anybody else do it differently? Yeah, Will, how'd you do it?
Square root of 4 and square root of 9 is the square root of 36.
Okay, so in his head, he's just multiplying the two radicals, and he gets this, which turns out to be what? 6. So did you make the assumption that I can do this? I can just take a radical times a radical and get 36, and then just take 36. Did you know that coming in here? No, he's just kind of guessing, and he guessed right. But that is correct. When you take a radical times a radical, you just take the numbers inside, multiply them, get 36. Square root of 36 is what? 6. But why did John? Why did John just do it this way?
Order of operations.
Well, yes.
Because he's John Lewis.
Mr. Foston, right, John.
You guys are supposed to say, because it was so easy, these are perfect squares. These are so easy. Square root of 4, 2. Square root of 9, 3. If you have perfect squares, don't waste your time going this way that Will did. Just say that's 2, that's 3. 2 times 3 is 6. That's not always the case. You don't always get easy numbers inside. So this is probably the way we're going to go today in our assignment, this way. And then they tell you this right here. If you have the nth root of A and the nth root of B, and they're real numbers, they have to be real. They can't be imaginary. Then, look, it says if you have the nth root of A times the nth root of B, it's just what? Nth root of A times B. And the nth root just means any root. But as long as the roots are identical, you can do this property. So you can only multiply radicals, radical expressions, if the blank are the same. The what? The root. Okay, I didn't write root, just so you know. I wrote what?
Index.
The indices. Now, listen, you can say roots if the roots are the same, like Travis did, but it's the index. If the index is exactly the same, go ahead and multiply. So the question becomes, what if they're not the same? What do I do?
You add?
Okay,
You multiply.
you can multiply if the indices are the same. What if they're not the same? Then you cannot multiply. That was what I'm trying to get you to say. You can't multiply. You can only multiply if the indices are the same. All right, so let's go.
What if you multiply the indices?
That's not a problem. You can't do it. Okay. Oh, hang on. Mr. Kohlmeyer was here yesterday, and Mr. Kohlmeyer and I talked really fast yesterday. I said, make sure they do this before they listen to the recording. And I don't think he did, but in the recording I said,
Yeah, you said Mr. Coons, and I was really confused. That was,
yeah, Mr. Coons called in sick. Here's the deal.
oh my.
Here, see this?
Yeah.
Mr. Kohlmeyer, I don't know if he said it, but you were supposed to have copied the perfect squares, perfect cubes, fourth powers, fifth powers to make life easier for you. This is a cheat sheet you can use on any assignment, any quiz, so you don't have to keep typing your calculator. You can look over here and say, what's the cube root of 27?
Can we do one of the things like
3.
Schmidt does it?
What's the cube root of 256? 4. So you can look at your little cheat sheet, okay?
Do you
All right.
know Schmidt does it?
What's that?
Like the triangle thing.
You can do that if you come in 7th hour.
I
Okay.
have class.
Yeah, well, get out of class.
I'll come.
Whoa, sorry. Here we go.
Here's the date.
Can you multiply radicals? that radicals that have the same root.
Yeah.
Yeah. So this times this would be
81 squared.
square root of what?
81.
81. Which kind of turns out nice. Is that a perfect square?
9.
9. Okay. Now, some of these, when you start your assignment, will be very easy for you. They'll just be, oh, that's nice. 9. 9 times 9 is 81. But they get much tougher as you go, so be careful here. Okay. Can you take the fourth root times the fifth root?
No.
No. We talked about this in the very beginning. The indices have to be the same, 4 and 5.
Wait,
They're
wouldn't A be plus or minus 9 because they're even?
Oh, I'm so glad you said that. Hang on.
Hey.
Okay. So Annalise says, isn't it going to be plus or minus because it's an even root of a positive number? The answer is yes. But, just so you know this, when you did your problems yesterday, they always said this. Find all the possible real solutions. So, if they ever say that to you, they want you to put the plus or minus sign. But if they don't say it to you, you don't have to put the plus or minus sign. But if Annalise puts this on her quiz, am I going to count that wrong? No, I'll never count it wrong. It's just that you don't have to in this one. So really the only section that talks about give me all the possible real numbers is section 6.1. So on the quiz, it'll probably be the first 2-3 problems. After that,
When's our first quiz?
you don't even have to worry about it. Next week sometime. Look at your calendar. Okay, is this times this possible?
No.
No. So I'm just gonna write, it's already, what? Simplified. It's done. Don't do anything. You don't have to. Okay? That's actually the one you want to see because there's no work to do. You just say, simplified, done. Do you think it's on the quiz?
Yes.
Yeah, it's on there. And you know what happens? 10% of the students say 7 times 7 is 49, in the fourth root of 4, and they keep going. You can't do it. Okay, cube root times a cube root. Can you do it? Yes. Hey, are these perfect cubes by chance?
Yeah.
Is 128 a perfect cube?
Yeah.
Look at the cubes. No. Is 4 a perfect cube? 8 is. No. So these are not like, remember how John did it? John just took the square root of this, square root of that, he got answers quick. You can't do it here. You have to multiply. So it's going to be 500 something. 512. Okay. So what's the cube root of 512? Bam, it's right there. Now see, you could take a calculator and do it, and you type it in. You'd eventually find it. It's just 8 times 8 times 8.
That's on tests too.
What's that?
Can we do that thing on tests?
Yes, that's why I want you to copy it. I do. I'm trying to save you time. And you know what you're going to eventually do? Memorize these. You're going to memorize them. You won't even be looking at them. Okay? Yeah. Okay. Next, can you take a square root times a square root?
Yeah.
Sure. Square root of? What? Yep. Okay. Now, yesterday, you kind of saw this yesterday. It's what? No solution. It's not possible. I heard you say it. So no solution. You cannot take the square root or fourth root or sixth root of a negative number. Once you see even, you know you can't take even roots of negative numbers. No solution. Another one you are looking forward to seeing on your quiz. That's such an easy one. But you can't forget that. And the next one says the square root of 40 times the square root of 20. I don't think either one of those are perfect squares, so I got to multiply. What is it?
800.
800. Okay, now here's the problem. You got to simplify. You can't leave it as a square root of 800. So now your memory says when I simplify radicals, I look for perfect squares that go into 800. Look at your list. What goes into 800 evenly?
100.
Right there. 100. 100 does. How many times? 8 times. Right? Square root of 100 times 8. What's the square root of 100? 10 times the square root of 8.
Square root of 8.
Square root of 2.
I'll write that.
1, 2.
Yeah, but I was going to ask you, is 8 simplified?
No.
No, somebody said it, 4 and 2, right? So you'd probably change this to 4 times 2. Okay? Square root of 4. 2, square root of 2.
Square root of 2.
Yeah, you don't know. Of course, the two numbers out in front make 20. There you go. Right? Now, there is a way you could have done it a lot faster. I felt like I heard one person say, there's a larger perfect square that goes into 800.
400.
400. You guys could have said this is really just 400 times what? 2. What's the square root of 400 though? 20. So you would have got there a lot faster. But the problem is most of you know your perfect squares up to 144. And maybe you know a little further, but most of you don't memorize past 169, 196, 225. What's the square root of 225?
17.
15. 15 times. You know, when I was in your chair, I knew up to 225. After that, I couldn't memorize it, or I just didn't want to memorize it. I just kind of quit.
You go to school in Air Force.
I did. Yes.
Are you a Central boy or a regular boy?
I can't tell you.
That's where they're
You think so?
Well,
You'd have to look in my yearbook. Okay.
well, if you lived at Central, you would have told us.
Can you please bring in your yearbook?
If I can find it, yeah. It's been so long.
Okay, well, bring it tomorrow, or I will tell the principal.
Oh!
That's your homework assignment.
No.
I'll have him dock your pay.
Do you have a fro?
Okay.
You have a fade.
No, he definitely had
I
a
don't
flat
know it.
top.
Let's go. Let's go. Simplify. Hey, we just did this, and we actually practiced with variables. Square root. Is 125 a perfect square? No. 100 is. 121 is. Not 125. Can you break this up? Give me a perfect square. 25. Yep. Times 5. There you go. X to the 6. Now we talked about variables. If the power of the variable is divisible by the index, it's good.
X cubed.
That's good. Don't change this one.
Okay.
Okay. What about y to the 5th?
X squared and y. I mean y squared and y.
That'd be y cubed. Don't you want this to be
shoot.
y to the 4
I
and
tried
y?
so hard.
Right? Just go
I
one.
tried to do that too much in my head.
Find the largest number divisible by 2 below 5, and it's 4. Okay, then you just have to do one at a time. Square root of this. Right? Okay, square root of this. Followed by this, which is what? Y squared.
That's where I meant to put that.
Oh, I got you.
Yeah.
Now, you guys, you've used up all of this. What's left inside?
5 and a y.
Okay,
The little 6.
there you go. That would be it. These answers get really ugly, so when I read them off tomorrow, you gotta be really listening well. 5x cubed y squared times the square root of 5y.
Is there a signage on the wall? You know?
Well, I don't know. Just depends how good you are. Not so good.
When's the quiz tomorrow?
The next one is the cube root.
Next Thursday.
Guys, this is the hard part. The hard part is you have to shift gears. In your mind, you're doing cube roots. Is 128 a perfect cube? No. So you got to break it up. Well, go below 125. What goes into 128 evenly? 64 times 2. So you should be saying the cube root of that times that. Okay. Then you gotta look at your power of x. It's 7. 7 is not divisible by the root 3. So we're gonna change x to the 7th to x what? 6 and 1. Right? That's it. Once you do that, guys, it gets much easier. All right, what's the cube root of that number? 8 times 8, that would be the square root. You want the cube, it's 4. Now listen, look here. Cube root of 64, come back here, it's 4 times 4 times 4. Okay, so 4. You know this one, I hope. Cube root of x and 6. X what?
Squared.
Yeah, it's just 6 divided by 3. The rest of them you don't know, so you leave them in there. Cube root of? Not just, yeah, 2x. Okay, the 2 I don't know and the x I don't know. 4x squared times the cube root of 2x. Good? Another cube root. Try it. Look for perfect cubes. They go into 135. Did you find it? Aaron, do you have one? Do you have a perfect cube? 27. 27 times what? 5. Okay. Okay, yeah, that was it. It was 27 we were looking for. It goes into 135 5 times. Okay. A to the 4th, not the greatest power. Change it to what?
8 to the 3 times 8.
Yep, there you go. Try and get a multiple of 3.
Thank you.
Okay, b to the 14th, not so good. Change it. b12 times b squared. Okay. If you can do that little bit of changing, then you know a lot of these. You should know this one, and that one. Cube root of 27. 3. Cube root of a cubed. A. B to the 12th. B to the 4th. Okay. That's about all you know, guys, right there. The rest of the stuff inside, you just don't know. So the cube root of all the rest would just stay in there. 5 AB squared. And wait a minute. I should have a cube in here. You need to keep the cube in there because if you don't, then what you wrote is wrong. Okay? Yeah, then it would look like the square root, right? Okay, once again, I'm going to ask you to shift gears. We're not doing cube roots, we're doing 4th roots. Switch gears. Get in that 4th power column. Got to rewrite it. Just do it. Let everybody kind of figure it out. $162 is not a perfect 4th power, but there are perfect 4th powers that go into it. Which one? 81, yeah. 81 went into 162 how many times? Twice. 9 is not the greatest power. We'll just change x to the 9th to x what? Times x. Okay. How about y to the 10th? Yeah, just drop down to 8 because 8 is divisible by 4 times y squared. But you get all that in there, it's pretty simple. Take this out. 4th root of 81.
9.
I knew that was coming. You did the square root.
Oh, shoot. Yep.
It's 3, isn't it? 3 times 3 times 3 times 3. Okay. 4th root of this one. x squared. This one,
Y squared.
y squared. Okay, done. I'm just done. Now I gotta just kind of understand the rest of it. I just don't know this, the fourth root of. Times the fourth root of.
2xy squared.
Good?
Yeah.
Okay, so what you did, you basically multiplied the top, took it times each other, then simplified. Here you just simplified. Now when you go to the bottom or the next page, it's just multiplication. So they want you to multiply the two radicals and then simplify. It's kind of what we have been doing, but these get really messy, so be careful. All right, first one is, first one is square root of this times square root of that. But guys, look at the numbers. They're huge. So when you multiply these two huge numbers, you're going to get even bigger. Right. Do you want to simplify really big? Or would you like to simplify right away? I personally, I like to do it right away. Okay? All right. So I do this. I go the square root of 45. Is there a perfect square that goes into 45? What? 5 and 9. Okay. So I like 9 because it's perfect. I'll put 5 second. Okay. So 45 is just 9 times 5. Okay, 35. Is there a perfect square that goes into 35?
Are we not doing the rest of the variables yet?
Well, we'll do variables after we do numbers.
Oh.
Okay. Just, but yeah, I'm asking 35. Is there a perfect square that goes into 35? 25? No. 16? No. 9? No. 4? No. No. Okay. But you know what I could do? I could rewrite that smaller. So what's two numbers that give you?
75.
Okay. You said 7 times 5. I'm going to reverse it and go like this. Okay. Any ideas why I reversed it?
Because
That's how you
it
do
puts the
it.
fives together.
Yeah. If you put the 5s together, it makes what?
5 squared.
25. You know the square root of 25?
7.
Yeah, this is a perfect square. That's why I wanted the 5 with the 5. Okay, now, the variables, x to the 5th times x to the 1st, guys, when you multiply x, 5x's times 1x, you get x what? No,
6.
5 of them plus 1 more, 6. So the rule is when you multiply like variables, you add the exponents. Okay. Y to the 3rd times y to the 4th.
Make it 5 to the 6.
Y to the 7th. Good? Alright. Now there's one thing about this that I don't like, and it's y to the 7th. I change it to what? Y6 times y. And this is why I said it gets kind of messy. Some of you can do these things quicker than others because you just see it better. What's this? Square root of 9.
3.
Okay, you've got to realize what you have. That's just 25. 5. And then, of course, you've used all this up. Square root of 7, do you know it?
No.
No. This one?
X of
X to the 3rd, 6, divided by the root 2. Okay, what about this?
y to the 3rd.
Yeah, y to the 3rd. Okay, this is 1, and you don't, 1's not divisible by 2. So let's just quit there, I guess. And all that's left is
7 square root of 7y.
7y. Okay. And of course, you could probably change that to what? 15. So we could, okay. I'm just going to write it, I guess. 15 x cubed y cubed times the square root of 7y. There you go. You okay? These are just messy. I wouldn't even call them hard. I just say you're gonna get some of these wrong because you went too fast. Okay. The next one is a square root or a cube root or a fourth root. Cube. Go. I think you can handle this right now. I'm just gonna kind of trail you. I'll trail you by a minute. This one is slightly different. It has a number on the outside and another number on the outside. What are you gonna do to them?
Times the number.
This would just take the numbers on the outside. They're called coefficients. Multiply them, get -8, right? Nine is not a perfect cube. 6 is not a perfect cube. I'm just gonna multiply them. 9 times 6 is what? Yeah. And the reason I multiplied these two is because it's such a small number. I can simplify 54 pretty quick. C to the second times C to the seventh. C to the ninth. D to the fourth times D to the seventh. D to the 11. Yeah. Okay. Whoops, and I forgot my cube. Cube root. 54 is not a perfect cube. But I bet there's a number that goes into it. That is a perfect cube. 1? Yeah, you're right. But 1 never helps.
8.
9 is not perfect. Look here.
What is it?
Here's your choices.
22?
20 what?
7.
Yeah, 27 is a perfect cube. It goes into 54 how many times? Twice. So you should do this. 27 times 2 is 54. Is C to the ninth a good or a bad power? That's a good power. Leave it.
Evil.
What about D to the 11th?
No.
Change it to D to the ninth times D squared. Okay? You have 3 numbers that are perfect cubes in there. The 3 numbers are this one, these 2. Okay? So what's this going to be? -8 times cube root of 27. 3 times C to the ninth, C cubed, D cubed, times whatever left.
2.
Cube root of 2D squared. Okay. And of course, the coefficients are what? -24 C cubed D cubed times the cube root of 2D squared. Hey, just so you know this, when you look inside a radical, if the power inside 2 is smaller than the index, you're done. You get it? If this was D to the 4th, you're not done. You got to keep going. Since that's a 2 and that's a 3, you are done. Okay, try the last one. Let me come by your desk and say yes or no. Got it? Yeah, that's it. Yeah, that is it. Okay, so you know what you're doing. Just keep going. I'll book assignment. One person has it. Yeah. Yeah. Put it away. Right. You put it away. Got 5 minutes on. Keep going. Better? Yeah. Oh, right here. This is the 4th root, not the square root. So the 4th root is equal to 2. So that's 4 divided by 4. Oh, 8 divided by 4 is 2. 4 divided by 1. Yeah, that is good. That's good. I have a question. Yes. I don't think y squared is right. And I think this is supposed to be 2y's. Something's wrong. Something's wrong. Just a little bit. It's okay. It's a small one. Negative times negative is positive, whatever. Square root times square root. That's the square root of negative. Okay. Quick. We got 3 minutes. Ready? You can take 8 times 4 because it's fourth roots. 32. X to the what? 8. Y to the what? 5th. Okay? You're not going to listen and be quiet. Fourth root of 32. Is 32 a perfect fourth power? No. But what goes into it? 16 does how many times?
Twice.
Twice. Okay, so you should have probably put this times this. Is 8 a good power? Yeah, don't change it. Y to the 5th? No. Change it to what? Yep. This one, now be careful. What's the fourth root of 16? Yeah, a lot of students put what here? They do the square root, they put 4. Okay, this is going to be x to the 2nd. This is going to be y. What's left inside? Fourth root of. I use this, and this. 2y. And we can change this to what? 4. So the answer was 4x squared y times the fourth root of 2y. I only got 2 or 3 people that had it right when I walked around.
I did have Mr. Baker.
No, I don't.
I did, I'm serious.
Never told me no.
I know I didn't. I didn't want to waste your time.
Oh. Nice.
Yeah, okay.
Are you one of those teachers that's like,
You in there all day.
2 minutes at the end of every class?
You get an hour of
Are
detention.
you one of those teachers that you waste 2 minutes at the end of every class hour for a whole year?
Yeah. What was it?
I don't know, but are you one of those teachers?
You should be like Mr. White.
Well, you should know. Do I say
Mr. Peter, you should be like Mr. Kohlmeyer.
I should be like Mr. Coleman. Why?
You have a 2 minutes before the end of class, it's an hour of detention.
Ah, yeah, I should be.
That's why he's asking.